analysis is a useful technique to convert units. It uses a series of conversion factors, such as 1 gram equals 1,000 milligrams, or 1 kilogram equals 2.2 pounds. The next few minutes will teach you how to change units using dimensional analysis. Whenever you see the stethoscope, pause the video and practice on your own. Then resume the video and see if you got the correct answer.
Also, here's a few common conversions you'll want to become familiar with. Let's get started.
The doctor prescribes 40 milligrams IV of furosemide. If furosemide is available in 20 milligrams per milliliter, how many milliliters should be administered? To start, I'm going to go ahead and say that we want milliliters at the end, because that's what I want my answer to be at the end. And then I'm going to take what's given, which is the 40 milligrams. I'm going to write that as a ratio over 1. Now I got to change milligrams to milliliters, so I'm going to multiply by 1 milliliter over 20 milligrams given from the problem. What you'll notice is that my milligrams are opposite each other. In order for the milligrams to cancel, they must be on the top and the bottom. So now that the milligrams are gone, I'm going to go ahead and multiply the numerator, which is 40, multiply across the denominators, which is 20, and then I'm going to reduce. So 40 over 20 gives me 2 milliliters. The doctor orders 625 milligrams of Tylenol. The bottle indicates that it is 250 milligrams per tablet. How many tablets should the patient receive? Let's check your work. Start with the word tab on the right side because we want to get to tablets. From the problem, we know that we need to administer 625 milligrams of Tylenol. So from there, I'm going to multiply that by 1 tablet over 250 milligrams. Multiply across the top and the bottom, 625 over 250, and then reduce, and if I simplify, I should get 2.5 tablets. Now let's see some problems that have multiple conversions. The doctor prescribes an IV of normal saline solution to run at 125 milliliters per hour. The drip factor given is 10 drops per milliliter. At how many drops per minute will you run the infusion? To start, we're going to put drops over minutes on the right. Now the problem states that we have 125 milliliters per hour. So let's change the hours to minutes. Multiply by 1 hour over 60 minutes. The hours cancel. Now let's change milliliters to drops. From the problem we know that there are 10 drops in 1 milliliter. So the milliliters cancel. Multiply across the top and the bottom, 1,250 over 60. Finally, let's reduce, and we get 21 drops per minute. The doctor prescribes an IV of 2,000 micrograms of morphine. You see that morphine comes in 4 milligrams per milliliter. How many milliliters of morphine do you need to draw up? To start, we will put milliliters on the right, because that's what we want to get to. The doctor prescribed 2,000 micrograms. So now to go from micrograms to milliliters, we first have to change micrograms to milligrams. So there is 1,000 micrograms in 1 milligram. Micrograms cancel. Multiply that by, from the problem, we get there's 4 milligrams in 1 milliliter. Cross cancel again. So 2,000 milliliters over 4,000. And then if I reduce, I get 0.5 milliliters. Let's end with one that has lots of conversions. The healthcare provider prescribes dopamine at 5 micrograms per kilogram per hour for a 140-pound patient. The medicine comes in a pre-mixed solution of 500 milliliters with a concentration of 3.2 milligrams per milliliter. The infusion device should be programmed for how many milliliters per hour? Milliliters per hour on the right. From the problem, there is 5 micrograms per kilogram per minute. Let's first change minutes to hours. So multiply by 60 minutes per 1 hour. The minutes cancel. Now let's change micrograms to milligrams. 1 milligram is equal to 1,000 micrograms. So the micrograms cancel. Now let's go from milligrams to milliliters, and that's from the problem. We know that there is 1 milliliter and 3.2 micrograms. Now let's change from kilograms to pounds. So 1 kilogram is 2.2 pounds. Okay, so we will see that the kilograms cancel. From before we had the milligrams cancel. Finally, we get to multiply by 140 pounds because the patient weighs 140, and you'll notice that the pounds also cancel. Now we are left with milliliters over hours, and so if I multiply across, it would give me 42,000 over 7,040, and I am in milliliters per hour. And finally reduce, so 5.97 milliliters per hour.